For my Marine Community Profile project, I examined and explored the Ocean Beach Estuary, which is part of the San Diego River Estuary. This estuary is located in Point Loma near SeaWorld and Mission Park. The entire San Diego River is 52 miles in length and has a watershed of more than 440 square miles. However, during my trip, I was only able to explore about a mile length of the actual estuary. A diverse variety of animals rely on the salt marsh estuary for various biological functions and throughout different times of their life cycles. Many birds rely on this area for hunting grounds, nesting sites, and breeding grounds, including endangered species like the western snowy plover, California least tern, and the light-footed ridgeways rail. It's also a critical habitat for other organisms like fish, invertebrates, mammals, and amphibians. The mixing of sand and mud, as well as wave and current action, create a wavy-looking pattern in the sediment. And the asymmetrical wave ripples on some part of the estuary also point to breaker waves with unequal intensity in opposite directions, producing bottom oscillations. The changing flow of salt water from the ocean and fresh water from the river also fluctuate the salinity levels, which means it takes resilient species to survive in this environment. The vegetation of the marsh can also change sediment distribution, which can change the overall physical structure of the marsh. This can lead to the creation of channels and mounds, as well as create 3D habitat within the rhizomes of the vegetation underneath the water. This brings me to the first species I'll be diving into, which is Spartina alterniflora, otherwise known as salt marsh cordgrass. Salt marsh cordgrass comes from the kingdom Plantae and phylum Tracheophyta. This cordgrass acts as a foundational species within this estuary environment. It helps catch sediment, which creates habitat and also provides nursery grounds for larval species. It also acts as a food source because it can be consumed by detritivores once it dies and decomposes. This cordgrass also acts as a primary producer because it converts sunlight into energy through photosynthesis. It also helps filter pollutants from runoff and is a source of carbon sequestration. There was obviously a ton of salt marsh cordgrass present because of it being the foundational species for this community. The next species I'll be introducing is the Sternula antillarum brownie, otherwise known as the California least tern. The California least tern comes from the phylum Chordata. This estuary is a critical habitat for the endangered California least tern, which uses this wetland as a nesting site. They live in California as a seasonal resident from April to September and use these grounds as breeding, nesting, and feeding sites. This species often nests in areas with sparse vegetation, often close to estuaries, which they use as feeding grounds for targeting small fish. I unfortunately did not see any California least terns while I was there, but it is also out of season to see them. The next species I'll be talking about is the Leptocotis armaturae, otherwise known as the Pacific staghorn sculpin. These guys come from the phylum Chordata. These fish begin their lives in estuaries as larvae and will either move upriver into more freshwater areas or continue to live within the brackish estuary itself. They feed on amphipods, invertebrates, and other small fish that live in the estuary. They help keep smaller fish populations in check as a predatory species and also as prey for other larger predatory fish like striped bass. They have an ability to tolerate a wide range of salinities, which allows them to live in diverse habitats within the estuary and connected river. I saw some larval fish within the water itself, but due to the high turbidity, it was difficult to make out what fish I was seeing exactly. The fourth species I'm going to be talking about today, the Neotypea californiensis. otherwise known as ghost shrimp. They come from the phylum Arthropoda. They live in intertidal mudflats and sandy substrates within estuaries. This salt marsh estuary had a substrate that was more of a silty sand type, which is perfect for ghost shrimp to burrow in. They create extensive, deep tunnel systems beneath the sediment, which helps to bioturbate the sediment and create complex microhabitats that attract other invertebrates, which can use these tunnels for protection and food. They feed on plankton, bacteria, and detritus through deposit and filter feeding methods. While I didn't see a ghost shrimp directly, I did get video evidence of some kind of burrowing organism within the sediment that caused trapped air bubbles to be released out into the water. Through my research, I determined that this was one of the potential species that could have been burrowing within the sediment in this estuary. The last species that I'm going to be talking about is the Mugelcephalus, also known as the striped mullet. This organism comes from the phylum Chordata. They're found in a variety of coastal areas worldwide, including temperate and subtropical waters of Southern California. While they are native to coastal waters, they can also enter freshwater streams and tolerate high salinities. I was able to determine this was the fish my boyfriend and I saw when exploring the estuary because it would jump out of the water. Unfortunately, however, as much as we tried, we failed to capture them jumping out of the water on video. But here's a YouTube video of what it looked like. They do this to escape predation, dislodge parasites, and also for oxygen intake. They also jump out of the water when migrating to spawn in salt water and hatch their eggs in the open ocean before the larvae return to the estuaries. Their peak spawning season is from October to February. So this could be why we saw them jumping in the water while moving in the direction of the ocean. They are bottom feeders that ingest a variety of food, including algae, detritus, diatoms, and bacteria. They have small mouths, which they use to sift through the sediment to find their food. They are a primary consumer, which help convert detritus and algae into a food source for larger animals. They're also prey to a variety of larger animals like fish, birds, turtles, and snakes. Unfortunately, the estuary community I profiled is subject to numerous issues. The environmental challenges that my community faces is the presence of invasive plant species that outcompete the native salt marsh cordgrass, which can lead to habitat loss. This part of the wetland is also right next to a dog beach, so we saw many people there with their dogs who were often unleashed. While we were there, my boyfriend and I witnessed dogs trampling through the cordgrass, dislodging sediment when digging and playing, harassing the birds that use these areas, and pooping and peeing on the beach, which can cause excess nutrients and potential pollutants to enter the water and negatively impact the estuary. And because this beach is a hotspot, not only for dog owners and their pups, but the local community as a whole, we also saw some litter within the estuary environment, which further pollutes the habitat. There's also a harbor entrance on the other side of the estuary, separated by a jetty where we saw many recreational vehicles coming and going. The presence of these boats could potentially lead to things like fuel and oil spills, the discharging of chemicals from things like cleaner fluids and paint, as well as the potential release of untreated sewage into the waters. There's also an ongoing issue with untreated sewage, polluted stormwater, and trash flowing down the Tijuana River and dumping into the Pacific Ocean near Imperial Beach. This has led to previous closings of Ocean Beach, where the San Diego River meets the Pacific Ocean, as well as the closings of many other beaches, because this polluted water has made it as far north as Coronado. This poses a serious threat to the surrounding marine ecosystems, as well as health risks to the local communities. Fortunately, many agencies and organizations, both governmental and non-governmental, are trying to help protect, preserve, and restore this estuary and many others like it. One foundation, called the San Diego River Park Foundation, have several projects, from educating the local community about the issues facing marine estuaries around the San Diego River, to coordinating volunteer cleanups, collecting donations to acquire land around the San Diego River to protect the watershed and wildlife, and leading community-driven initiatives to preserve safety, access, and recreation of these areas for the local communities. Another organization is the Surfrider Foundation, which is fundraising for border water infrastructure improvement projects, leading organized events for activism and community outreach, and helping campaign at the federal and state governmental levels to reduce the flow of pollution. They're also collecting signatures for petitioning the President and Congress to address this as a national emergency. And government agencies like the US EPA are working toward implementing a permanent solution to the Tijuana River crisis. Thank you for watching. This has been my community profile of the Ocean Beach Estuary in San Diego, California.